In this video, we will learn about nuclear energy, energy obtained during specific nuclear processes, example nuclear fission, due to conversion of a small fraction of mass into energy is called nuclear energy. Nuclear fission is the reaction in which nucleus of an atom splits into two or more smaller nuclei. To understand nuclear energy, let us first learn about mass energy equivalence and nuclear fission process. First, let's understand about mass energy equivalence. On the basis of his theory of relativity, Albert Einstein derived the famous mass energy equivalence relation. According to this relation, if in a given process mass delta m is lost and this loss of mass reappears as energy, whose value is given by E is equal to delta mc square, where E is energy, delta m is the mass lost, and c is the speed of light in vacuum, where c is the speed of light in vacuum having a value of 3 into 10 to the power 8 meter per second. From the above equation, it is found that if one atomic mass unit, that is 1 U, of mass is transformed into energy, then an energy of 931 mega electron volt is released, where 1 U is equal to 1.66 into 10 to the power minus 27 kg. Now let's understand about nuclear fission. The word fission means breaking up or splitting up, and the word nuclear is related to nucleus. So, nuclear fission is the process of spontaneous splitting up of the nucleus of a heavy atom such as uranium 235, plutonium 239, or thorium 233. It splits into two lighter nuclei along with the release of large amount of energy of about 200 mega electron volt when bombarded with low energy neutrons. In the nuclear fission process, the combined mass of lighter nuclei formed is slightly less than the mass of nucleus of the heavy atom. It means that some mass has been lost in nuclear fission process and consequently tremendous amount of energy is produced in accordance with mass energy equivalence. We know that mass energy equivalence states that E is equal to delta m c square, where delta m is the mass lost in nuclear fission. Actually, it is found that fission of one nucleus of uranium 235 atom produces 10 million times the energy produced by combustion of an atom of carbon from coal. The energy produced in nuclear fission process is called nuclear energy. When a nucleus of uranium 235 undergoes a nuclear fission, after being bombarded by a low energy neutron, three neutrons are produced. This means that we bombard the nucleus of uranium 235 by one neutron, but in the process of nuclear fission, three neutrons are produced. These produced neutrons may trigger fission in three nuclei and in turn may produce still more neutrons and so on. In this way, a self-sustained nuclear chain reaction can be set up. If the nuclear chain reaction is controlled in such a way that out of three neutrons produced as a result of fission of one uranium nucleus, only one neutron is allowed to cause further fission and remaining two neutrons are either absorbed or removed from the assembly, then the fission reaction continues at a controlled rate. This is known as controlled chain reaction and it leads to generation of nuclear energy at uniform rate. So we know that to generate nuclear energy at uniform rate, we need to either remove or absorb two extra neutrons from the assembly. This controlled chain reaction of nuclear fission is achieved in a nuclear reactor. This over here is nuclear power plant. Now let's understand harnessing of nuclear energy. Nuclear energy released in a controlled nuclear fission process of uranium-235 known as nuclear fuel is utilized to generate electricity which can then be conveniently used in our houses, establishments and for industrial use. For this purpose, special electric power generating nuclear reactors are designed. In a nuclear power plant, nuclear fuel, which is generally uranium-235, undergoes a self-sustaining fission chain reaction at a controlled rate in a nuclear reactor. The tremendous amount of heat energy produced due to fission process taking place in nuclear reactor is quickly removed and used to convert water to superheated steam. So we know that in nuclear reactor, the process of fission is taking place, and because of this process of fission, a tremendous amount of heat energy is produced, and this heat energy is used to convert water into steam. And this steam is then utilized to run the turbine in order to produce electricity. Moving ahead, let's understand advantages of nuclear energy. Main advantages of nuclear energy are as follows. A. A nuclear power reactor can produce a large amount of useful energy from a very small amount of nuclear fuel like uranium-235. B. The conversion efficiency of nuclear power reactor is comparatively high. C. If a nuclear reactor is loaded with nuclear fuel, the nuclear power plant can continue producing electricity for few years. There is no need for putting a nuclear fuel again and again as we have to do in the case of coal or gas-based thermal power plant. Now let's understand disadvantages of nuclear energy. Main disadvantages of nuclear energy are as follows. A. The main hazard of nuclear power generation is the storage and disposal of spent or used fuel. The waste products of nuclear reactor are known as spent fuel and is highly radioactive and may continue to emit harmful radioactive radiations for a long period. Thus, it is extremely necessary to store and dispose nuclear waste safely and is very difficult and risky. Improper nuclear waste storage and disposal may lead to widespread environmental contamination. Next disadvantages: there is a risk of accidental leakage of nuclear radiation from a nuclear reactor. Such accidental leakage from a reactor may cause serious damage to mankind as well as plant kingdom over a large area around the nuclear reactor. C. The initial installation cost of a nuclear power plant is very high. D. Availability of fissionable uranium-235 is limited. I hope this topic is clear to you. Thank you.